What is a periodic motion? A periodic motion which is one which repeats itself in regular interval of time, such as Earth revolving around the Sun and the Earth orbiting around its own axis. It's recording here. So these are all periodic motion. You know, this gets repeated every 24 hours. This gets repeated every 365 days. So that's periodic. Similarly, now oscillation of a pendulum is also periodic. But the difference between this and this is only periodic. This is periodic and simple harmonic. Periodic as well as simple harmonic, because every time it causes the mean position goes to the extreme position. So when the particle moves to and fro about the mean position, it's called oscillatory motion. It's called periodic. It's periodic as well as simple harmonic. Every simple harmonic motion will be periodic, but every periodic is not necessarily simple harmonic. Okay, that's the basic thing. So next is so then Fourier just said that sin theta, if you can express a function as sine, one single sine function or cos function, it's always periodic. See, sin theta plus one time period should give you sin theta itself. Imagine, no, sin theta plus 2 pi in the first quadrant will give you sin theta only. Similarly, cos of theta plus 2 pi will give you only cos theta. The function gets repeated after every interval of the first quadrant. Can you see 2 pi plus is the first quadrant? So he just generally said that if you can express a function as a sine or a cos, then obviously it will be periodic. Okay, are you clear? So next is some graphs have been given here. So this graph which has been given, can you see this is definitely periodic, but you can't call it simple harmonic because it's not crossing the mean position. So therefore it is only periodic and not simple harmonic. Then another graph has been given in Aurora, which is this graph. Can you see this also getting repeated? But however, and this is crossing mean position, but it's not a sine graph or a cross graph. So then therefore it is periodic, but it's not simple harmonic. If it has to be simple harmonic, it should be able to express it in the form of sine or a cos function. Are you clear? So there's one more graph which has been given like this. Again, you know, it's repeating, but it's not simple harmonic because it's not a perfect sine graph or cos graph. So you know that sine is periodic because you know every first quadrant it is getting repeated. 2 pi plus theta sin theta. Cos is also repeating. If you tan graph, if sine graph pathina, it's going like this. So you know it's crossing the mean position and going like this. So it's simple harmonic. Cos is like this. So you know that it's again simple harmonic. Tan is like this. You cannot call this simple harmonic. Why? Because here it's tending to infinity. Anything which tends to infinity or minus infinity, it is not periodic. Periodic should be period time. It should not be tending to infinity. So that completes this. Okay, so let's go to next. Therefore, you understand tan, secant. Secant also is going to tend to infinity. So anything where the function is tending to infinity, then obviously it will not be simple harmonic. It will not be periodic also. Are you clear? So next is the first question in the book. An average heartbeat is beating 75 times in 1 minute, which means 60 seconds. In 1 second, how many times will it beat? So x into 60 is equal to 75. X is equal to 75 by 60. That will give you the number of beats per unit second. Correct? So that is frequency. This is hertz. You can always cancel this and write it. It will be 1.25 hertz. They ask you time period. Time period is simply the reciprocal of frequency. 1 by mu is time period. You know that, right? So therefore 0.8 seconds. The first question is answered. Then example 2. Here they are given two functions, sin omega t plus cos omega t. They are asking you whether it is periodic, simple harmonic. First, it is periodic because let's take this omega. Individual sin and cos functions will always be periodic. You know that the first quadrant 2 pi plus, it's going to be recurring, correct? So even otherwise, you take this omega, it's 2 pi by capital T. Time period is 2 pi by omega. Take this omega, which is 2 pi by capital T. Time period is again 2 pi by omega. So both of them are going to repeat itself in the time period of 2 pi by omega. So therefore it is periodic. But the question is it simple harmonic? To prove it's simple harmonic, when they give you sin omega t plus cos omega t, you should always multiply and divide by root 2. You should treat this that there is a 1 here. And then multiply and divide by a root 2 and take the what is the denominator alone inside. So it will become root 2 into. Then write it as cos 45. Cos 45 sin omega t plus Sin 45 cos omega t, which is root 2 into sin omega t plus pi by 4. Has it come out as one single sine function? Therefore, it's definitely simple harmonic, where this is the maximum amplitude. You are this wave and I am this wave. You had an amplitude 1, I had an amplitude 1. But both of us have now combined together. We are producing a combined sine wave, and the amplitude of it has become root 2. Can you see it's basically root of 1 square plus 1 square. If this was A and this was B, it would have been root of A square plus B square would have been this. Okay, and now you should first understand in this, what is this pi by 4? Omega is the angular velocity. Omega is the angular velocity, which is 2 pi by capital T. What is this pi by 4? It's known as initial phase. Initial phase. I'll come back to this. This totally is the phase. This alone is called the initial phase. That's pi by 4 is initial phase. Okay, coming back, resultant amplitude. So this simple harmonic, that's all. Okay, let's go to next question. Sin omega t plus cos 2 omega t plus sin 4 omega t. Is it periodic? First of all, let's see. This cannot be simple harmonic, because there are 3 different functions. Enna multiply and divide pannalu, you can never convert it to one single sine function or cos function. So it is never going to be simple harmonic. But let's check if it's periodic. Omega is equal to 2 pi by capital T1. Capital T1 is 2 pi by omega. Here, 2 omega is equal to capital 2 pi by capital T2. Capital T2 is 2 pi by 2 omega. 4 omega is equal to 2 pi by capital T3. So capital T3 is 2 pi by 4 omega. So therefore you understand T2 is half of T1 and T3 is 1 by 4 of T1. Correct? So therefore, supposing this is school bell, it's very personal class bell, 11th standard, 12th standard, where they're ringing every 60 minutes. This they're ringing 30 minutes. The small classes were ringing 20 minutes. All the 3 bells will together bring in 16 minutes. You can ignore this. So the total time period will be periodic, and the time period will be 2 pi by omega. This is an example that I said. It's not 60, it's 2 pi by omega will be the time period. All the 3 bells, that's so it's periodic, and the time period at which all the 3 will repeat itself together will be 2 pi by omega. So let's go to next question. Next question is e to the power minus omega t. Exponential function, the graph is like this. Do you know this? And here it's tending to infinity. So you can't, it's not even periodic. But however, this is minus, so this graph is like this. It's getting reflected because of the negative sign. It's like this. But even then, it's tending to infinity. Anything which tends to, you don't have to bother with the graph. Anything where it is tending to infinity, therefore it is not periodic. If it's not periodic, where's the question of it being simple harmonic? No. So let's go to next. It's a logarithmic function. A log of omega t. You know how a log function is? Exponential function is like this. Log function will be like this. Image of this. Then again, it's tending to infinity. So then any log function, exponential function always tends to infinity. Therefore, it's not periodic. Are you clear? Therefore, it's obviously not simple harmonic. So there are some questions in the book back also. Some examples, not book back, Aurora, some examples. A sin omega t plus cos omega t. Yeah, you can express it as one simple sine function by multiplying and dividing by root 2. So it's 1 by root 2 sin omega t plus 1 by root 2 into cos omega t. So root 2 into this itself will become sin omega t plus pi by 4. So therefore it is simple harmonic, correct? So this is the maximum amplitude, and therefore simple harmonic. So let's go to next question. A sin pi t plus 2 cos 2 pi t plus 3 sin 3 pi t. You can never convert into one single sine function. Therefore, it is never simple harmonic, but it can be periodic. What is here? Pi. That's nothing but omega, no? Which is equal to 2 pi by capital T. Pi and pi get connected. T is equal to 2. What is here? 2 pi. So omega. In the place of omega, what is there? 2 pi is equal to 2 pi by capital T. So time period is equal to 1 second. What is here? 3 pi is equal to 2 pi by capital T. So time period is equal to 2 by 3 seconds. So all of them will repeat itself in the least common multiple time. I took 16, no? Like that there will be, you find the least common multiple 2, 1 and 3, 2 by 3. That will be the time when all the 3 bells will go together. Something like that. So let's go to third question. Is cos of 2 omega t plus pi by 3. Definitely one single sign function. It's simple harmonic as well as periodic. Let's go to next one. A sine square omega t. Sine square ella varakudadu. It has to be one single sine function, one single cos function. Even if you try to write it as 1 minus cos double angle by 2. You know this formula, cos 2 theta formula. Even then you cannot express it as one single sine function. But therefore it is definitely, it may be periodic, definitely. But it's not simple harmonic. Can I go to next question? Cos omega t plus 2 sine square omega t. Cos omega t plus 2 sine square omega t. You can never express this as one single sine function. It may be periodic, but it's not simple harmonic. That's all. Are you clear? So let's go to next. So therefore, what is simple harmonic motion? A simple harmonic motion is the one where you take, you have come across a simple harmonic motion in the spring constant lesson. Okay, you oscillate, leave this is the mean position. You pull it like this and leave it. It tends to oscillate to and fro. So that's what is. So whenever you know the restoring force is in this direction, while the displacement is in that direction. F is equal to minus k into x, where k is a constant. This is known as, in any simple harmonic motion, it should be of this form. That's when it will cross the mean position. A simple harmonic motion is one where the particle will cross over the mean position, to and fro about the mean position. So therefore the condition is F is equal to minus k into x. You also know F is equal to m into a. Equating both of this, ma is equal to minus k into x. Therefore a is equal to minus k by m into x. A is equal to minus omega square x, where omega square is what is called k by m. Omega is equal to root of k by m. Are you clear? So this is something you need to memorize. And if you want the two conditions for it to be simple harmonic, condition number 1, if it is of the form f is equal to minus kx, or a is equal to minus omega square x, where x is the displacement. Are you clear? So after that, this is they'll ask you for the differential equation. You know acceleration is d square x by dt square. Move this to that side, plus omega square x is equal to 0 is the differential equation of a simple harmonic motion. Is a differential equation of simple harmonic. Write a note on simple harmonic motion, express it as a differential equation, just write it and leave it. Are you clear? So next is, you know, you have to find the time period. You know omega is equal to 2 pi by capital T, time period is equal to 2 pi by omega. Omega from this lesson you know is root of k by m. So 2 pi into root of m by k will be the formula for finding the time period of any simple harmonic motion. Are you clear? Where m is called the mass factor or inertia factor, k is called the spring constant or spring factor. Okay, so let's go to next. Next is a uniform circular motion. Okay, so supposing any oscillation, say a body is, there are two types of oscillations, okay. One is an oscillation can start from the extreme position and end at the extreme position, or can start at the mean position, go to the extreme and then go to this extreme and then come back. The two dimensions in which you can consider an oscillation. When it's starting from an extreme position, you express it as cos, because in cos graph only it starts from the extreme position. So therefore you know that this has to be always expressed as cos, and this is to be expressed as sine, because it's sine 0 0. At time t is equal to 0, x is equal to 0. At time t is equal to 0, x is equal to a. It's the maximum amplitude from the mean position, where a is the maximum amplitude. Do you understand? So then you should understand that starts from mean position, we'll express it as sine, start from extreme position, cos. But in this lesson, the whole lesson which Aurora has dealt with, he's talking only about starting from the extreme position and ending with the extreme position. One oscillation is considered like this, not like this. We'll come to this later. I've released another video where I've explained this better, but come to this point and let's deal with Aurora. So now you know that an oscillation is going to and fro about the mean position. That too coming from the extreme position, crossing the mean position, going to the other end, and then coming back and going like this. So this can be depicted in the form of phasor diagram. See, for example, this is the origin. The particle starting from the origin, starting from the extreme position. So you project, supposing the particle is coming back from right side to the left side, it's come to this position. Project it on the circular motion. Circular motion is called the phasor diagram. Once you do that, you know the particle in actual should start from here. But there is a sum where the particle is starting from here. At time t is equal to 0, it's not here, it is at this point, which means there is an initial phase difference. Inga start pandra when you running racer, nee inga start pandra. So there is initially itself, there is a phase difference, correct? So that phase difference is because of this distance, correct? This variation. So if you project it on the circular motion only, the phase angle can be calculated, which is phi naught, which is called the initial phase. So at t is equal to 0, the particle is here. The particle which was here is got projected on the circular motion. Without projecting it on the circular motion, I cannot find the angle or the phi naught, which is called the initial phase. Initial phase na enartho? At time t is equal to 0, it is not starting from the extreme position. Instead, it's starting from some random point. And there is a phase difference from where it should have started and where it is now starting. And to understand that, you have to put it on a circular motion and project it on the circular motion. Consider this to be your initial point. And so you can find your phi naught, which will be your initial phase. Phase is an angle. So to find the phase, I cannot treat it as an oscillation, horizontal oscillation. I have to project it on the circular motion. Now from P, it's moving to another point, P dash, which means this angle is omega t. Therefore, the total angle, now I'm going to make this into a right triangle. The P dash into a right triangle. So then can you see the whole angle become omega t plus phi naught? And the displacement is always, the displacement from the distance is always measured from the mean position. X from the mean position. So then therefore I get it, a cos omega t plus phi naught. A cos omega t plus phi naught is equal to adjacent by hypotenuse. Hypotenuse, the entire radius is A, the maximum amplitude. So x is equal to A cos omega t plus phi naught is the displacement equation. And how did he get it? And you should understand what is the meaning of phi naught. Phi naught is the initial phase. Initial phase na inga arambikkanum ana inga arambikkude. Time t is equal to 0, starting point வேற எங்கேயோ இருக்கு அப்படிங்கிறது. அதுலேருந்து ஒரு omega t மூவ் ஆயிருக்கு, omega t plus phi naught. So x is equal to A cos omega t plus phi naught. So thus you got your displacement equation like this. Are you clear? Now take this displacement equation, which means you've started it from the extreme position. That's why it's cos. Now you differentiate this, you get velocity. Differentiate it, you get minus A omega sin omega t plus phi naught. I'm sure you know differentiation chain rule. When you apply to t, there will be an omega additionally coming outside, correct? So this is your velocity. Suppose you want to find acceleration, you have to dv by dt. When you differentiate, sign will be cos. So minus A omega square cos omega t plus phi naught will become my acceleration. So you got your displacement, velocity and acceleration. Are you clear? So when you notice this, so this is the maximum amplitude A omega. This is the maximum amplitude of velocity. This is the maximum amplitude of displacement. This is the maximum amplitude of velocity. This is the maximum amplitude of acceleration. Takku formula A omega square A omega. So then therefore just take this and write it. Okay, x is equal to A cos omega t plus phi naught. I know that velocity is equal to minus A omega sin omega t plus phi naught. I know acceleration is minus A omega square cos omega t plus phi naught. And you know from the first equation, cos omega t plus phi naught is x by A. So substituting here, A is equal to minus A omega square into x by A, where A and A get cancelled. You got minus omega square x, which is a simple harmonic motion again. Okay, that is one. Okay, next thing that I want you to have a look is this velocity can also be written as v is equal to minus A omega root of 1 minus cos square omega t plus phi naught. And you know cos omega t plus phi naught is x by A. So minus A omega root of 1 minus x square by A square. So when you take LCM, A and A will get cancelled. You get minus omega root of A square minus x square. This is the velocity at any instant. Imagine, no, in this, what is x? X is 0, which means it is mean position. In mean position, velocity will be maximum. You know that. At the extreme position, what do you know? X is equal to A. The velocity will be 0, because A square minus A square will become 0. This is how you conclude that the velocity is maximum at the mean position and 0 at the extreme position using this formula, which was derived from here. This is one thing. With this you can also find kinetic energy, which is there in my next video. You don't have to worry. Now I'll take this one. Take the same thing again. You know, x is equal to A sin omega, x is equal to A cos omega t plus phi naught. V is equal to minus A omega sin omega t plus phi naught. Okay, and acceleration is minus a omega square cos omega t plus phi naught. Now I want to write this equation removing the negative sign. You should always understand that in this lesson velocity is ahead of displacement, acceleration will be ahead of velocity. Velocity displacement நீ ஓடும் ரன்னிங் ரேஸில் ஓடுறதுக்கு உட்கார உன் ஹார்ட் ரேஸ் ஆக ஆரம்பிச்சிடும். நீ சொங்கி மாதிரி உட்காந்து அப்புறமா வெலாசிட்டி பண்ண முடியுமா? யூ வில் பி லிட்டரலி லைக் திஸ், விச் மீன்ஸ் வெலாசிட்டி டிஸ்பிளேஸ்மெண்ட் நடக்கல, velocity is ahead of the displacement. சும்மா ஒரு எக்ஸாம்பிள் சொல்கிறேன். பட் you should know when you convert a sine into a cos. See, only if all the three are in cos, you can see who is winning there, who is faster, who is slow. One is cos, other is sine. You cannot compare. எல்லாத்தையுமே காஸாக மாற்றணும். ஸோ இந்த சைனை காஸாக மாற்றணும்னா I can do 90 minus theta, but I will do 90 plus because velocity is ahead. Velocity is ahead. 90 minus theta will also be complementary angle, which will give me correct cos. 90 plus also I can write, but I prefer to write 90 plus. So I'll write this as a omega cos omega t plus phi naught plus pi by 2, because a cos 90 plus is in the second quadrant where cos will be negative. That's why this negative is also there. And you should always write it as 90 plus. Are you clear? And acceleration பொறுத்த வரைக்கும் come here, you should write this as a omega square. The cos can be cos because the point is to convert everything into cos. But you should write this omega t plus phi naught with the pi to show that the difference between the velocity and acceleration is another extra pi by 2. So this is how you convert everything into a cos graph. Are you clear? That is one. Now coming back to next thing. So let's they'll ask you to derive this one. X is equal to minus a omega sin omega t plus phi naught using phasor diagram. அப்படி பண்ணா நீ என்ன பண்ணு, ஏற்கனவே டிஸ்பிளேஸ்மெண்ட் கண்டுபிடிச்சிட்டல. ஸோ திஸ் இஸ் வெலாசிட்டி. வெலாசிட்டி எப்படி கண்டுபிடிப்பேன்? Take a phasor diagram. Consider point here with the velocity v. Linear velocity is r times angular velocity. So it's a omega. And radius here is a. Join this. And this whole angle is omega t plus phi naught. You make sure that the particle, supposing the particle is coming from here to here with a velocity v of x. Just project this like this, project this like this, and so that the particle is also coming from here to here, and then extend this right triangle and join it like this. If this is omega t plus phi naught, this will also be omega t plus phi naught. If this is velocity, this is also v of t. So here you're going to do sin omega t plus phi naught because velocity is the opposite side in this triangle. Sin omega t plus phi naught is equal to v of t by a omega. Therefore v of t is equal to a omega sin omega t plus phi naught. But however, you should put a negative sign because velocity is pointing towards the negative side. So therefore insert a negative sign. That shows how this graph came. Are you clear? Graphically we have proved it. You understand? This is omega. I'll teach you once again. You look very blank. I don't know why you're doing this. Consider a point here. The velocity is like this, and linear velocity is r times angular velocity, which is a into omega. Supposing the particle has moved from a position a to b with a velocity v of t, which is in this direction. Project this is the initial point. This is the final point. So then construct it like this, and consider this as p and q. Whatever this is also v of t only. Extend it into right angle. This angle is omega t plus phi naught. Now by similar triangle, this is also omega t plus phi naught. Using this right triangle, sin omega t plus phi naught is equal to v of t, which is opposite side, by amplitude radius, which is a hypotenuse, which is a omega. So v of t is therefore a omega sin omega t plus phi naught. But what about the negative sign? Because it's directed towards this side, you can insert a negative sign. This is how you got this. Supposing they ask you to derive it using phasor diagrams. Next is they'll ask you even acceleration using phasor diagram. What is acceleration formula? Minus a omega square cos omega t plus phi naught. If I have to do this using phasor diagram, my acceleration is always pointing towards the center. it's a circular motion, which is radius is a, but acceleration, what is acceleration? Is v square by r, centripetal acceleration, which is linear velocity is r times angular velocity, r square omega square by r and r get cancelled, r is amplitude a omega square. Therefore you understand this is a omega square, okay, and is pointing towards the center, which means the particle has been here, it's moving towards the center, and this angle will be omega t plus phi naught again, is adjacent. Adjacent is some displacement x, some acceleration a of t, which is directed towards the center. This I am writing centripetal acceleration, but that is in the rotational motion. This is the acceleration of the oscillation. You understand? Two different things. So then therefore you write cos omega t plus phi naught is equal to, what is this? Acceleration a of t by the hypotenuse, which is a omega square. Therefore a of t is a omega square cos omega t plus phi naught. And can you see this is the maximum amplitude? Again you have to put a negative sign because it's again directing towards this. And you got this. Somehow you get this, that's all. These are the phasor, using phasor diagram how to get it. Using differentiation how to get it is very easy. Only the phasor diagram they ask you, it's going to get difficult for you. So the next is this graph, okay. This is very, very important. They are taking this x of t, which is simply an a sine a cos omega t. Again, everywhere you should use only cos in Arunda, because they are taking only cos. Extreme position in the oscillation starting பண்ண எடுத்துக்கறாங்க. Plus phi naught la illa. What is the meaning of plus phi naught is not there, which means at time t is equal to 0, it is at the extreme position and correct oscillator. There is no initial phase. Are you clear? So x is equal to a cos. Next year இப்படிலாம் பண்ணாத கரெக்டாக வரணும். Like serious business we are into, so you can't be chumma taking leave like this. Please down. I'm every time making it a point to somehow do something for you from the beginning, but you can't be taking me for granted. And next year I'll be in pressure. In the year I'm not in pressure. Next year I'll be in acute pressure, because every school will take different chapters. Please cooperate, okay? It is x of t. Suppose you know if you will differentiate, you get v of t, which is a minus a omega sin omega t, and acceleration is a minus a omega square cos omega t. That's all, you got all the three. Now you know how to write velocity. I told you a omega sin omega t plus pi by 2, and acceleration is a omega square, no, it should be cos, right? It should be cos. Everything has to be in terms of cos. So this also will be cos omega t plus pi, so that I am converting everything into cos, so that I can readily compare which is ahead. Acceleration is ahead by from velocity by pi by 2. Now they'll ask you to plot this, okay. First of all, this graph is so important. This tabular column is also important. So this is for a time 0, அப்புறம் t by 4, அப்புறம் t by 2, அப்புறம் 3t by 4, அப்புறம் 2t and t. One full time period gets broken down like this. These are the time periods. Similarly, you can also write it in terms of radians. Radians means 0. This will be pi by 4, this will be pi, 3 pi by 2 and 2 pi. The entire time period in terms of radians, correct? Now they're asking position. They're asking how are the positions. Say, take for example x set. X will be at the position, it's a cos graph, right? Cos, you put in this, what is cos 0? X is equal to a. Cos 0 is 1, so x is equal to plus a. So you know that x will be plus a at 0. And then at pi by 4, at pi by 4 or t by pi by 2, no? What did I write? Pi by 2. Cos 9t is 0. So x will also be 0. So therefore this will become 0. Then at this point it will be minus a. At this point it will be 0. And then at this point it will be plus a. So you understood. We are substituting in the cos omega t. Next let's write the velocity. Velocity at 0. What is velocity's graph here? It's a sine graph. At time t is equal to 0, velocity will be 0. At a time t pi by 2, sin 90. Sin 90 will be 1. So what is the velocity? Minus a omega. So it is minimum. Minus a omega. Then it's 0. Plus a omega. And then it is 0. This is the minimum velocity and this is the maximum velocity. Similarly, let's write acceleration.